My name is Heather, and I am an ambassador and volunteer with the American Association of Variable Star Observers, also known as the AAVSO.
Hi, my name is Anna Para, and I'm an ambassador for the American Associate of Variable Star Observers.
Greetings, Sky people. My name is Molly Wakeling. You might also know me as Astronomolly, or by observer code WMOB on AAVSO.
Hi everyone, my name is Skylar Larson and I'm an AAVSO ambassador.
My appetite to explore the universe emerged after binge watching Cosmos Space-Time Odyssey in my mid-20s. And soon after that, I enrolled in my local community college and took a course called Astronomy 101. And after completing that class, that's when I realized I had a big passion for astronomy.
I'm a PhD student at University of California, Berkeley, working on my doctorate in physics. And I've been doing astrophotography for about the last 5 years. And it's been just a real joy. Absolutely love doing it, and I'll probably never get tired of it. There's so many different things to do. After doing traditional astrophotography for the last several years, I've been wanting to get into scientific data taking, and I recently joined the AAVSO, and I finally got a rig put together of various bits and pieces to be able to take scientific data for the AAVSO and also for NASA's Exoplanet Watch program.
I am a beginner amateur astronomer. I'm interested in learning as much as I possibly can about our universe. And I'm here making this video as a member of the AAVSO Ambassador Leadership Team to explain to you what a variable star is. So what is a variable star? When a star, as observed from Earth or any observing point, starts to or has been behaving strangely over time, the first thing we notice is the star's brightness begins to fluctuate. The luminosity of that star is varying. The change in the emitted light can be caused by some pretty neat things. It could be a star swelling or shrinking, getting ready to explode its contents across the cosmos. We call that an intrinsic variable. Or there may be something partly blocking that light. It could be a cloud of dust or even an exoplanet. And causing an eclipse in front of that star. And we call that an extrinsic variable. Even our own sun, that thing over there, is a variable star. Its luminosity varies about 0.1% over its 11-year cycle. That's pretty cool. How do we measure a star's brightness changing? Well, by constantly observing it and documenting the magnitude. The apparent magnitude is what the star's brightness is. There's a scale there. Some stars vary over long periods of time and some really short. The data is used to monitor and predict what might be happening with that star. And if something really exciting is going on, the star will get a bunch of attention. Kind of like Betelgeuse recently, the second brightest star in Orion. It started to dim and do some pretty weird wobbly stuff into late 2019. But it has regained its brightness. We're still not 100% sure what caused that dimming, but there's been a few studies saying it's probably a cloud of gas, but I'm gonna let the experts look into that one.
Where do you even start? I started very early. I was a toddler when I started just stargazing with naked eye in my backyard, going to libraries to get all the books that I could possibly find on the subject, just researching about it on my own. And in high school, I was lucky enough to have the Boys Astro organization visit my school and teach a seminar about publishing a paper. Find your local astronomy community. There's bound to be a group of people in your area that study astronomy. Just get in touch. Nowadays, I am an AAVSO ambassador specifically for outreach and education. I make my own videos on astronomy topics that I like. As an MIT undergrad, I research centaurs right now. Centaurs are these little green dots, and they're like asteroid comet-like things. I'm trying to find satellites around them. But how exactly do I do that? Well, if you can't afford a telescope like I can't, I mostly specialize in data analysis. That's kind of taking images or data from a database that like somebody's already taken and kind of chugging it through some code and basically finding patterns in data You can do this in a lot of ways. You can find light curves with variable stars. You can find light curves with exoplanet transits. You can try to find satellites going around solar system bodies, kind of like I am. There are loads of ways to contribute to data analysis in astronomy.
At the end of the Astronomy 101 course, my astronomy professor offered me a spot in her team to study binary stars, which I happily accepted. Binary stars are two or more stars orbiting a common center of mass. My research experience was very rewarding because I got to strengthen my research skills, I'd made new friends, and I was one baby step closer to understanding the universe. After completing my binary star project, I was able to jump onto a new research opportunity that focused on exoplanets, planets that exist outside our solar system. With the support of the AAVSO, I was able to join a team that focused on exoplanet transits using a transit modeling software called AstroImageJ. My curiosity on exoplanets grew, and I found myself on NASA's website trying to answer some very important questions about exoplanets.
I'm going to show you my telescope setup and talk a bit about why I got into astrophotography and how I got into scientific data taking. So I'll give you a little tour of what I've got here in my backyard in the East Bay area of California. This is the science rig, which is the one I take my AAVSO and Exoplanet watch data with. This is a Celestron CGE Pro that is mostly functional. It's unable to guide at this moment, but the nice thing with doing variable star observing is you don't need the best guiding, you don't need the roundest stars, just round enough to be able to register them. On top here is a 8-inch Vixen Newtonian f4 telescope, 800mm focal length. I have an old Orion Starshoot Deep Space Monochrome Imager 2. I have a Starlight Express filter wheel that I have loaded with photometric filters, which is, you don't need to do photometry with AAVSO, but it's a type of observation that they like to get if you have those filters. And I have a RoboFocus focuser that I took off one of my other telescopes and attached to here, and it's been working quite nicely. One of the interesting things about doing variable star or exoplanet observing is that you don't actually need as high-end of gear or as precision of tracking as you need for doing deep sky astrophotography. A lot of times the exposures are only 30 seconds, 1 minute, 2 minutes, not usually very long exposures like I would do for my deep sky. These stars don't have to be as round. You know, you want nice round stars for getting nice looking astrophotography, but for data taking, the stars can be slightly elongated, have odd shapes, things like that. The only thing that really matters is that the exposure is not overdone and that they're round enough stars to be able to register and align. So the requirements for doing variable star data taking is actually much less than doing astrophotography, which surprises a lot of people. The cool thing about taking variable star observations, either on your camera or even visual if you're more of a visual observer, is that data that you take on the magnitude of that star on that given night, you can upload to the AAVSO website, and that gets collected into a database, and researchers can use that data in their research papers, and you can get cited in the papers, and it's a really great resource for the scientific community. You can contribute to the science doing because on these bigger telescopes they don't have the spare time to be taking data, but I've got all the telescope time I want. I don't have to dedicate it to other things. I run this thing doing variable star targets all night long, every night that it's clear. So you can contribute to a wide variety of science right from your own backyard. And if you're an astrophotographer, you can do it with equipment that you already have. It can be really rewarding to see your data show up on the light curve generator on the AAVSO website, and getting the emails that say that my data was downloaded as part of a data set that a researcher was using. It's a real joy to be able to know that the images that I've taken on the amateur side of the house are also being used for science in addition to the research I actually do for my PhD.
If you want to know more about the organization and what our members love about this aspect of astronomy, or get involved with the Ambassador program, please check out the website, www.aavso.org, and see what we're up to. Thanks!
Being a part of AAVSO has been a lot of fun for me, and I look forward to being able to share what I've learned about exoplanets to others and meeting folks who are curious about astronomy. So thank you for your time. Bye.
Clear skies.